Hello. Okay, so today I'm going to be telling you guys on how to solve this specific problem using CPV. Uh, yeah, so the formula for present value is cash flow over 1 plus 0.10, which is a 10% discount rate, to the power of the year, which T stands for right here. T is equal to the year number. So as you can see, the years go from 0 to 5, and at year 0, Project A has negative 50,000, same as Project B, negative 50,000, but the rest of the years differ. So at year 1, Project A has 10,000. At year 2, Project A has 15,000. Year 3, 20,000. Year 4, 25,000. Year 5, 10,000. Project B has at year 1 5,000, year 2 10,000, year 3 15,000, year 4 30,000, and year 5 20,000. Now to calculate present value, what I did was I did H4, which would be yeah, I did H4, which is year 1, divided by 1.1 over, not over, to the power of 1, because it's just year 1. So just gonna 1. So this is what I got. And then for this one, as you can see, the equation changes to 2 since it's year 2. And I did the same thing, and that's the number I ended up with, and so on. Year 3 was that. Year 4, year 5. And for project B, it was this one, this one, this one, this one, and that one. So over here we can clearly see year 0, it seems to be a control. It doesn't really change. But for year 1, the present value seems to be higher than project B. And for year 2 as well, year 3 2. But for year 4, it is less on project A. And for year 5, it's also less. Way less. But that isn't the deciding factor. That's only present value. So we have to check on the CPV. So this is how we calculate CPV right here. CPV year 0 plus present value year 1, and so on. So year 0 is negative 50,000. So H19 plus H12, which is just negative 50,000 plus the present value of year 1. Scroll messed up. And so we got that outcome. And then for this one, we did the same thing. We just moved upwards. Well, technically downwards, but you can see H20 plus H13. I just plugged in the formulas to make it legit. So we use this value in here. Shut up, H2. Okay, so we use this value right here to plug it into this formula, and then we continued so on and so forth, and we ended up with these values on project A. Year 0 is negative 50,000, obviously. Year 1 is negative 40,909. Year 2 is negative 28,512. Year 3 is negative 13,486. Year 4 is 3,589. And year 5 is 9,798. For project B, year 0 is negative 50,000. Year 1 is negative 45,454. Year 2 is negative 37,000. Year 3 is negative 25,920. Year 4 is negative 5,429. And year 5 is 6,988. Now, what did these numbers tell us? The real thing here is the graphs, um, this line, if we align them together, if we uh, merge them into one graph, then this line right here would be sitting right above this one right here. I just didn't know how to do it, unfortunately, but I can't really even show you. It just goes behind it. But yeah, but that's not all we need. We can just check the numbers right here, the ending numbers right here, to see which one is actually better. So for project A, oh shoot, for project A, uh, at year 5, the value is 9,798.449, and for project B, it's 6,988, which would mean that because project A ends with the higher cumulative present value, I would choose project A because it adds more value at the 10% discount rate. It it really it really doesn't matter how much loss, how much it was gaining over here at present value, because the CPV actually tells you the deciding factor. So I would recommend project A. And yeah, that is it.